physics students. Today we are going to be revisiting acceleration and talking about describing motion with diagrams. So a visual representation of motion and kind of coming to some conclusions about an object's motion through these visual diagrams. So I just want you all to maybe take a quick little self-test and see if this is intuitive or just makes sense right off the bat. So I want you to look at these three diagrams, and each of these dots represents 1 second in time. So it's the position, meaning the location of an object at second 1, 2, 3, 4, 5, and so on. And so just looking at these diagrams, I want you to kind of answer two questions. Which of these motions describes acceleration? And which of these motions here is there zero acceleration? So which diagrams have acceleration? Which ones don't? Okay? The second question I want you to ask yourself, or answer, is which of these diagrams shows an object speeding up and which shows an object slowing down? In all of these diagrams, the object is moving in this direction. So pause the video and think about which one of these have acceleration, which of them do not. And remember that each one of these dots is 1 second. So pause the video here and give it a shot. Alright, so let's talk about this. So each of these dots is 1 second at a time. And what do we notice about each of these dots, or the space between each of these dots? That space is equal. We're traveling an equal distance each second in time. And if I'm traveling an equal distance, remember velocity or speed is how much distance I travel per 1 second or 1 minute or 1 hour per time interval. And so if I'm traveling the exact same distance every single second, is my speed changing at all? If you answered no, you are absolutely correct. So in this example up top here, my acceleration is equal to 0. And remember, the units of acceleration are meters per second. My acceleration is none. There is no acceleration in this because every single time interval we're traveling the exact same distance, meaning my speed is not changing at all. So our acceleration is 0. We are traveling this way at a constant speed. All right. This example, what's happening to the distance between our dots? Well, it's getting bigger and bigger and bigger. So as we travel, at 1 second, we travel a little bit. 2 seconds, we travel a little bit more. 3 seconds, we travel a little bit further, so on and so forth, until down here we're traveling quite fast. Or quite far. Well, if I'm traveling more distance in the same amount of time, hopefully we know at this point that that should probably mean we are going faster. We're moving faster. If I'm moving at 1 centimeter a second, I'm at a crawl. But if I'm moving 300 miles an hour, I'm whizzing by and I'm traveling really, really fast in that time period. So this visual representation shows that as time goes, we travel further and further distances in that same time period. Therefore, we're getting faster and faster. And so whenever we see a picture where we're moving this way and the dots are getting further and further apart, that means we're traveling further and further distances in that 1 second, meaning we are accelerating. So our acceleration is to this direction, and we are speeding up here. Speeding up. So we are speeding up, getting faster. Now, how about this picture right here? We're starting out we have a big distance, slightly smaller, so on and so forth, until we are barely moving in each consecutive time interval. And so, if we all of a sudden are covering a lot of distance, and then smaller and smaller and smaller distance, this image shows me that we are slowing down. We are traveling less distance in the same 1 second, and therefore I'm not going as fast during the subsequent seconds. And so, this right here, we are slowing down. Now, which direction do we think our acceleration is going to be in? We have our velocity, we're moving in this direction, but now we're slowing down. And from the last video that you all watched, you should know at this point that whenever our object is slowing down, that our velocity and acceleration point in opposite directions. So my velocity is this direction, we're slowing down, so my acceleration must point the other direction. And so my acceleration is going to be this direction, to the left or in the negative direction. Hopefully this is helpful in interpreting some of the homework problems. There are other visual representations on your homework. Some have little cars, like so, with like a little person in them. Same thing as the dots, just pay attention to what the spacing between the objects. Each picture of the object, again, represents a snapshot or a little picture every single second in time. And so really we're just comparing the distance between each picture and judging if the distances are getting bigger, smaller, or staying the same. Hopefully that's helpful. Let me know if you have any feedback on these videos. I'd love to hear what you think so far. Thanks for watching. Have a great day.